नमस्कार बच्चों, मेरा नाम धन्या और हम लोग ग्रेड 11 ऑर्गेनिक केमिस्ट्री का लेसन सीख रहे हैं। आज का टॉपिक है नेमिंग और एरोमेटिक कंपाउंड्स। ओके, सो aromatic compounds, so those that have benzene ring. So today we will be learning about the compounds that have benzene ring. So benzene, the formula is C6H6. It has 6 carbon and 6 hydrogen atoms, and it is represented by this structure having alternate, double, and single bonds. Okay, and there are 3 single bonds and 3 double bonds, right? Now, the benzene ring can also be denoted like this, where the double bonds takes the different position than structure 1. This is structure 1 and this is structure 2. So that means these double bonds are delocalized. Delocalized. Delocalized means they are not, the position of the double bonds is not fixed. So that is why there is a hybrid structure for the benzene ring. This is the hybrid structure for benzene, showing the delocalized structure of double bonds. So double bonds can be, double and single bonds can be alternate, and either structure 1 or structure 2. The double bonds and single bonds can be in any position. It can be as per structure 1 or structure 2. So a hybrid structure was developed, showing that the position of double bonds is not fixed. It is delocalized, and this is the resonating structure of the benzene ring. So more about resonance you will be learning later. Okay, so for now, the benzene ring has structure 1 or structure 2. That is why the hybrid structure was developed. Okay, because double bonds are delocalized, not fixed at a particular position. Okay, now some of the namings that we are going to learn is first structure. Okay, so here the numbering will start from the carbon atom having the benzene ring. So we write there's no other substituent except the bromine. So at the first position, I have bromo, benzene. Because the bromine is at the first position, I can just write bromo, benzene. Okay. Now, if you have a structure like this, where you have 2 substituents, bromine and NO2, the nitro group. Okay. So here, the numbering will start from the carbon atom having the bromine group, because here we have to go by the alphabetical order only. Okay, so 1, 2, 3, 4, 5, 6. We will try to give the position such that nitro group also gets the lowest position. So suppose if I number it the other way around, 1, 2, 3, 4. Here also nitro is getting the 4th position. So either way it is correct. So here we are looking out for the alphabetical order. So at the first position, I have bromo. At the fourth position, I have nitro, benzene. Okay. Coming to the next question, which is very important. So this is the benzene ring. I have bromine. I have nitro group, and I have chlorine. Okay. So here, how to number it? Now here, chlorine, looking at the alphabetical order, if I give chlorine number 1 position, okay? Sorry. If I look at the alphabetical order, suppose, so bromine is given number 1. So getting the lower numbers for all other substituents. So this is 2nd, 3rd position, 4th position, 5th position. So our substituents are in the position 1st, 3rd, and 4th. Now, our alphabetical rule must be the last option. Where there is no option left, then only we look at the alphabetical rule. Now, our objective is to get lowest positions for the different substituents. So, if I give the numbering like this, chlorine is given, the carbon with chlorine is given number 1 position, nitro is given the 2nd position, I mean carbon having nitrogen is given the 2nd position, 3rd, follow the black numbering, okay, 4, 5, 6. Okay. Now, if you go with the black ink numbering, chlorine is given 1st position, nitro is given the 2nd position, and bromine is given the 4th position. Now, if you see over here, the first position is okay, but here it is the 3rd position, here it's the 2nd position. So definitely we will go with this numbering, with the black numbering, because here the substituents are getting least number. So we will not follow the alphabetical order here, and alphabetical order should be the last option, okay, where there is no option left. So this numbering is wrong. This is our correct option. So alphabetical order must be, the alphabetical rule must be our last option, okay? So our name is, while naming, we will go with the alphabetical order: 4-bromo, 1-chloro, 2-nitro, benzene. Okay, so in the previous one, there was either way we number, it was the same. So that is why we went with the alphabetical order. But in this case, we checked the 2 types of numbering, and we saw that this numbering gets substituents its lowest position. Okay, I hope I am clear here. Okay, moving on next to the next compound. Suppose I have a compound like this with CH3. This is nothing but methyl benzene. And the common name which you would see in the textbook is toluene. Okay, this name toluene is written so many times, or you will come across toluene a lot of times in the textbook. Okay, similarly, there is another compound here like this, C2H5. There's an ethyl group, so this is ethyl benzene. I hope I'm clear here. Okay, so these are the names that you must know. Then, especially this toluene, some common names you need to memorize because you would come across in the textbook. Okay. Then, the next compound is CH3, CH3. There are 2 methyl group. So here, either way, you can give this number 1, number 2. So 1, 2, how many methyl groups are there? Dimethyl, 2 methyl groups, benzene. Okay. Similarly, another compound where the position of CH3 has changed. Here 1, 2, 3. So this is 1,3-dimethyl benzene. Similarly, CH3, CH3. This is 1, 2, 3, 4. 1,4-dimethyl benzene. Okay. Now, here there is another representation for this. Suppose any group is in this position, okay, and corresponding to this group, okay, if any substituent is coming in this position, this is referred to as ortho position. If the substituent is I'm talking about with respect to this position, if any substituent is coming in this position, it is called as meta. And if any group is coming in this position, it is called as para. Okay, so in textbooks, ortho, para, and meta is used sometimes. So this position is also called as ortho because with respect to this one, it is ortho and this is meta. So coming back to this again, 1,2-dimethyl benzene. This is also called as ortho because this methyl with respect to this is in the ortho position. So ortho dimethyl benzene. This methyl with respect to this methyl is in meta position. So meta dimethyl benzene. And this methyl with respect to this methyl is in para position. So para dimethyl benzene. So this also you would come across in the textbook. So it is important for you to know this. So ortho, meta, and para. Okay, I hope I'm clear here. Moving on further. Whenever there is a benzene ring, there's an OH. Okay. IUPAC has given a name for this and it is referred to as phenol. Okay. Then again, if there's a benzene ring and there's an aldehyde group, IUPAC has given a name for this benzaldehyde. Benzaldehyde. Similarly, there can be another name, an alternative name for this, because here the carbon, this is a terminal functional group which was discussed in the previous videos, where the functional group has a carbon atom and it can be the end of the chain. It can come at the end of the chain and it cannot be numbered. And here the carbon of the functional group is directly connected to the ring. Alternatively, it can also be written as benzene carbaldehyde. But commonly you will come across benzaldehyde more, but it can also be written as benzene carbaldehyde because the aldehyde is a terminal functional group and it has a carbon which is directly connected to the ring. Okay, so, but benzaldehyde is the more common IUPAC name or IUPAC name. Similarly, there's a benzene ring and C double bond O, CH3. Now, this is a ketone. Now, Here, in ketone, so the next compound you can see it's a ketone. Okay, so there is a ring and there is a straight chain. So definitely this will be a main chain because this has the functional group. So at the first position I have, when benzene ring, this is benzene. When the benzene ring becomes a substituent now, we don't call it benzyl, but we call it as phenyl. So C6H5 here, it has become a substituent. We call it as phenyl. So at the first position, I have phenyl. There are two carbon atoms in the main chain, ether, all single bond, ethane, one one. One is for ketone. Okay. So this is the IUPAC name. But here, there is a common name, very important common name that this compound has is acetophenone. You will come across acetophenone in some textbooks. Okay. So instead of writing the IUPAC name for this compound, they just write acetophenone. So this is acetophenone. So in grade 12, you have the whole lesson on ketones and aldehydes. So you will be learning about acetophenone. So you don't have to worry about it, but just to keep you informed. Okay. And there is one more common name for this particular compound. This is methyl. This is phenyl ketone. So one more common name that you would come across is methyl phenyl ketone. So these are the two common names for this particular compound. In this, acetophenone is more commonly used. I hope I'm clear here. Okay. Coming to the next compound. If you have a benzene ring, CN, C triple bond N, this is the nitrile group, cyanide, okay? So this is called benzonitrile. And here, again, there's an alternative name because CN is a terminal functional group. Okay, it can come at the end of the chain. And here there's a carbon directly connected to the ring. We call it as benzocarbonitrile. This was discussed in one of the videos, IUPAC naming of cyanide. Okay, so this was discussed. Here the carbon is directly connected to the ring and it is not counted. So that is why we use carbonitrile, but the more common IUPAC name is benzonitrile. Okay. Then the next compound that we have is acid. The most commonly used IUPAC name is benzoic acid. Here also, because the carbon is directly connected to the ring, we can also use as another IUPAC name, which is called as benzene carboxylic acid. This was discussed in one of the videos of IUPAC name of acid. Okay, when the carbon is directly connected to the ring and it cannot be numbered. But the more common IUPAC name is benzoic acid. The next one is C double bond OCl. Okay. So here, the IUPAC name is benzoyl chloride. Benzoyl chloride. This is the more common IUPAC name. But because this is also a terminal functional group, it cannot, here the carbon is directly connected to the ring, and if it cannot be numbered, it is also called as benzene This was also discussed in one of the videos. Benzene carbonyl chloride. But the more common IUPAC name is benzoyl chloride. You will come across mostly this name in textbook, benzoyl chloride. Okay. Again, the next compound is CONH2 amide. Here also, the more common IUPAC name is benzamide, and because here this is also a terminal functional group, the carbon is directly connected to the ring. It can also be called as benzene carboxamide. But benzamide is more common IUPAC. Okay, so here all these whatever we are discussing are the IUPAC names. Okay, all are IUPAC names. Okay. For some, I'm discussing some common names also, which are very, very common, but all these are IUPAC names. Okay. So here this was benzamide. Benzamide is more common IUPAC name, but some books also write it as benzene carboxamide because here the carbon is directly connected to the ring. Okay. The next compound is ester, COO, ester, and it is alkyl alkanoate. So we write the ester as alkyl alkanoate in IUPAC name. So here the alkyl group is nothing but methyl. So methyl benzanoate. Okay. And here also, so this is the most common IUPAC name, but here the carbon atom of the ester is directly connected to the ring. We can also write it as methyl benzene carboxylate. But the more common IUPAC name for this ester is methyl benzanoate. Methyl benzene carboxylate is a rare usage, but methyl benzanoate is more commonly used IUPAC name. Okay. Now, coming to ether, OCH3. Ether is ROR dash. Okay, so one of the R is alkyl group, one of the alkyl group is, or one of the one R can be methyl and the R dash can be phenyl or vice versa. Okay, now the IUPAC name common or the IUPAC name is alkoxy-alkane. Alkoxy is for the smaller chain and for the bigger chain is alkane. So the smaller one is what? Methoxy, right? So methane is smaller one, so methoxy benzene. This is the IUPAC name. Okay, and here we have a common name which is methyl phenyl ether. So methyl phenyl ether. But this is the common name, okay, not IUPAC, this is common name. IUPAC name is methoxy benzene, alkoxy alkane. Alkoxy is for the smaller group or the smaller chain, and alkane is for the bigger chain. So methoxy benzene. So this also in the video it was done about ether. Okay, nomenclature of ether or naming of ether. I hope I'm clear here. The next compound is amine. So here we can write benzene, and at the amine, since there's no other substituent, amine is at the first position. Benzene 1 amine. This is the IUPAC name. We also call it as aminobenzene. But the more common or more accepted name that the IUPAC has given is aniline. You will come across aniline, the name aniline, a lot of times. And you have a whole lot of lesson on amines in grade 12 where you will learn about aniline. So this is the IUPAC name for aminobenzene. Okay, so this is the name that you would come across mostly. I hope I'm clear here. Okay. Now, the next, if you have two OH groups, okay, you have benzene, first position and second position. So 1, 2, diol. Right? You can also write it as benzene 1, 2, diol. Now, similarly, two COOH coming near each other. So same way, similarly, we number it 1, 2. So I'm not numbering the rest of it because there's no substituents, right? And it's a benzene ring, it's understood. So benzene 1, 2, dicarboxylic acid, because there are two acid groups. So dicarboxylic acid. Okay, so here you can number it as what? Ortho benzene, ortho dicarboxylic acid. Okay. So similarly, if you have aldehyde group, so 1, 2, 3. So you have aldehyde groups at the first and the third position. So benzene 1, 3, dicarbaldehyde. Have bromine group. You have acid. Now you have CHO. There are so many functions. There are so many groups here. Now, here there are more than one groups or more than one functional group. Only one can be the primary functional group, which is based on the priority, which was done in the previous video about the polyfunctional group. So there the order of priority was given. According to the order, the acid is the primary functional group. So we give position 1 here. So bromine and CHO has become substituent. Okay. And we have to number it. Okay. Now suppose if we number it from here, 1, 2, 3, 4, 5, 6. So here, if we number it the other way around, like suppose this is always acid is a primary functional group, so it will get the first position, second, third, fourth, 5, 6. Right. So here, either way we number, the substituents are at the third and the fifth position. So we number according to the alphabetical order. Okay. So we will use the red numbering here. Okay, because the substituents definitely are getting the third and the fifth position. Okay, one of course is the acid because it's a primary functional group. Right. So either way we number the substituents, that is aldehyde and bromine are getting third and the fifth position. So we go according to alphabetical order. At the third position, I have bromo. At the fifth position, I have aldehyde. When aldehyde is the substituent, we call it as formyl. So formyl benzoic acid. So aldehyde, sorry, benzene ring with acid group is benzoic acid. Okay. Again, you have an amide group here. You have aldehyde group here. You have cyanide group here. Okay. Now here also there are 3 functional groups, but only one can be the primary functional group. That is nothing but the amide is the primary functional group. So definitely this carbon will get number 1 position. And the cyanide has become the substituent and aldehyde has also become the substituents. So they are now just the substituent. So when we number it, always primary functional group will get the carbon with the primary functional group will get number 1 position, that is the amide. So we will give aldehyde carbon, the carbon connected to the aldehyde, the second number, okay, because we also have to take care that the substituents are getting the lowest positions. Because if we number from this side, 2, 3, here the cyanide is getting the third position. So we will not number from this side. Instead, we will number from this side. 3, 4, 5, 6. Okay. So, but the naming is according to the alphabetical order. So when the cyanide is the substituent, it is cyano. When aldehyde is the substituent, and if it is not given any number, it is called, the carbon of the aldehyde is not given any number, it is called formyl. So 5 cyano, 2 formyl, benzene with amide, benzamide. Okay, now this reminds me of, here you can see in this example, we have done this example. Here you can see that there are 2 aldehyde groups that are directly connected to the ring. Okay, we have not given any number to that aldehyde carbon. So that is why we call it as carboaldehyde, 2 of them. Okay, so this type of examples was given in naming of aldehydes. Okay, so we wrote it as dicarbaldehyde because here the carbon of the aldehyde is directly connected to the ring, and this carbon of the aldehyde is not given any number. So carbaldehyde. Here there is an ester. So we will do some examples with ester. Okay. OCH3. This is cyanide. This is OH. So you have multiple functional groups. So one will be the primary functional group, which is ester. Primary functional group is the ester. So the carbon that is connected to the ester will be given the first position. Then I have two substituents, OH and the cyanide. So when cyanide is the substituent, it is called cyano. When OH is the substituent, we call it hydroxy. Okay, now ester, the name is alkyl alkanoate. Okay, so alkyl is the CH3 group. You always write the alkyl group first, and alkyl is the portion that is connected to the carbon. So alkyl means alkyl is the part I'm talking about ester here. So alkyl is the part in this, the alkyl is the part that is connected to oxygen. So here, which alkyl is connected to the oxygen here? The methyl. So here, first I write the name of alkyl group that is connected to the oxygen first. So methyl. Now, at the numbering, here, if I number from this side, 2, 3. And if I number from this side, 2, 3. Both the substituents are getting the third position. So in this case, we will go with the alphabetical order. Okay, so we go with the alphabetical order. We will not number from this side. Instead, we will number from this side where cyano, C is first, then H, 4, 5, 6. Because both the ways the substituents are getting the same numbers. Okay, so 3 cyano. At the fifth position, I'm getting hydroxy. Then alkanoate is benzoate. Okay, so this is how the ester is written when the ester is the primary functional group. So alkyl group is named first. Alkyl group is the one that is connected to the oxygen. So we will take a few more examples of ester. Okay. O, CO, CH3. Okay, so alkyl alkanoate. And I told you alkyl is the part that is connected to oxygen. So which is our alkyl part over here? So this is our alkyl part that is connected to the oxygen. So it is not benzyl alkyl group. Alkyl is the phenyl part here. So this is the phenyl that is connected to oxygen. So that is the alkyl part here. Okay, so that is the alkyl part here. So phenyl. So this part is called what? Alkanoate. It is nothing but there are 2 carbon atom if you number it. So 2 carbon atom means ethanoate. Okay. So alkyl alkanoate, alkyl part is the one that is connected to the oxygen. So I named it, and then the rest of it is the alkanoate. Okay. So here, C double bond O, C2H5, COOH. Okay, now here one more group will add CHO. So here the primary functional group is the acid. If you look at the priority list, so this carbon is given number 1 position. So either way, so this has become the substituent. So substituent, if ester has become the substituent, it is called alkoxy carbonyl. So in this case, ethoxy carbonyl starts with E. Okay, so ethoxy carbonyl. Okay, now this is the aldehyde group. When aldehyde becomes substituent, it is called formyl. So either way we number, the substituents are getting the same position. So we follow the alphabetical order. Okay, so So 3, 4, 5, 6. Because either way we number, the substituents are getting the same position. So 3 and 5, third and the fifth position, the substituents are getting. So we go with the alphabetical order. Okay. So at the third position, the naming also according to the alphabetical order. Naming is always according to alphabetical order. 3-ethoxy carbonyl. Fifth position, I have formyl and benzene with acid is benzoic acid. Okay, I hope I'm clear. Then, coming to the next question. So we are covering mostly all the types now, almost covered. Okay, OH, NH2. Okay, so here definitely the OH group is the primary functional group. And we already learned a while ago that whenever there's a benzene ring with the OH group, this is called as the IUPAC name is phenol. So this is given number 1 and this is given number 2 position. So this is the primary functional group. So we write it as, and when NH2 becomes the substituent, we call it as amino. So 2-amino phenol. Okay, because this is the phenol. We can also call it as ortho-amino phenol. Because the amino group with respect to phenol is in the ortho position. Remember, if there is a group here, any group in this area with respect to this group is ortho position. So we have almost covered different types. One more question. COBr, COH, OCH3, OC2H5, COOCH3. Okay. Now here, and one more group I'll just include, COOH. Okay. Now, looking at the rest of the group, the acid group is the primary functional group. The rest everything has become the substituent. So this is our substituent, which is haloformyl. So in this case, it is called bromoformyl because there's bromine halogen. Okay. OCH3 group is methoxy group. Methoxy group. Okay. Always OR is alkoxy. Okay. So if I see OCH3, it is methoxy. OC2H5 is ethoxy. So that means this is ethoxy. Okay. And this is the ester group, COOCH3. So this is nothing but methoxycarbonyl. Ester is methoxycarbonyl when it becomes the substituent, alkoxycarbonyl. Okay, alkoxycarbonyl when it becomes a substituent. And this CHO is formyl. Now, if this is the functional group, the carbon atom will be given number 1 position. This carbon has become number 1 position. Now, there are functional group in all the, or there is substituents in all the carbon atom connected to all the carbon of the ring. So we go according to the alphabetical order. So bromo. So this carbon is given number 3. So 4, 5, 4, 5, 6. So writing the name now. At the second position, I have bromo, formyl. At the fourth position, I have ethoxy. Then writing it down, okay? Sixth position, I have formyl. Fifth position, I have methoxy. Then at the third position, I have methoxycarbonyl. And the primary functional group is the acid. So benzene ring with the acid is called benzoic acid. Okay. So students, we try to cover a lot of questions on the naming of aromatic compounds. Okay. So thank you. Have a great day.